Hello everybody. So today we are starting a new topic. And that topic is called an antiderivative. And I hope that sounds like something that you could probably understand based on what you already know. Think about it like this. We learned what a derivative was and how to calculate a derivative. And now this term, without me really telling you anything about it, would suggest that maybe we're going to go the other way. We do this a lot in math. Like for just about anything that we do in math, it's usually a two-way street. Okay, I can't say all the time, but most of the time it is. So for example, at some point in your education, you learn how to multiply, right? You say 2 times 3 is equal to 6. And then once you get that down, once you get good at multiplying, then you learn how to factor. And that's just the reverse of multiplying. And you say, okay, well, 6, how do I factor 6? What do I multiply to get 6? And you say 2 times 3. So it's kind of like that, where all I'm looking for now is a procedure, perhaps, for finding whatever it is that if I took the derivative of it would give me what I have, okay? All right, so that's what an antiderivative is. Now, in this video, I'm just going to introduce the vocabulary surrounding it, the symbols. Math always involves lots of symbols, the concepts, and I'm going to keep everything very basic in this video. And then over the course of, 2, maybe 3 more videos, we'll develop that into solving more complicated problems. Okay, so here's the setup for what we're going to do. You see this right here. This is our problem. This is the notation that's telling us what we're going to do. This elongated S is called the integral sign. And what this collective expression is asking us for is what is the antiderivative of that function right there, 2x. Okay, so I can look at this whole thing and I can see it or interpret it as saying, what is the antiderivative of 2x? Meaning, what would I take the derivative of to get 2x? Okay, so all right, I got this elongated s, that's called the integral sign. This is the function I'm looking for the antiderivative of. And this thing right here, this dx, that's called a differential. And what it does is it indicates what variable we're using. It indicates what the independent variable in the problem is. And in this case, if I say dx, that will indicate that the variable is x. But the variables can change in problems, and we might see something different. Like right here, this says dr, so that's indicating that the variable is r. And this says dt, and that's indicating that the variable is t. But that's collectively what we have. All right, the integral sign, the function that we're looking for the antiderivative of, and this thing that's called the differential that indicates the variable. Okay, now collectively that expression is called an indefinite integral. Okay, so I know when we get started on something new, there's lots of new terminology, but that's it. That's the vocabulary surrounding what we're going to be into. The main idea is that if you can look past all the symbols and all the vocabulary, is that can you figure out what you take the derivative of to get 2x? And if you could figure that out, then that would be the answer to this particular question. All right. So let's explore like some of the answers. So let's see. Would this be an answer right here? Let's see. Let me prove my handwriting. There we go. Would it be correct to say that the antiderivative of 2x is x squared? Would that be right? Okay, what would make that right? The derivative with respect to x of x squared is 2x. Yeah, so that would be correct, okay? That the antiderivative of 2x is x squared, okay? All right, and it's just like my factoring problem. Why is it correct to factor 6 as 2 times 3? Well, because 2 times 3 is 6. There's no other answer to it. That's just how it is. It's a two-way street. So let's see. All right, x squared's an answer, but it looks like I could give you some other answers. Would it also be correct to say the antiderivative of 2x is x squared plus 17? So yeah, that would also be correct because the derivative with respect to x of x squared plus 17 is also 2x. Why is that? Well, because the derivative of x squared is 2x, and then I would carry my plus sign into my work if I was finding the derivative. And then the derivative of 17, well, 17 is just a constant. The derivative of any constant, whether it's 17 or anything else, is 0. So yeah, the derivative with respect to x of x squared plus 17 is 2x. So this could also be an answer. All right, it works, okay? And now just for dramatic effect, I'll give you one more. Would it also be correct to say the antiderivative of 2x is x squared minus 7.4218? Would that also be correct? Yeah, that would also be correct for the same reason this last one was correct, okay? That the derivative with respect to x of x squared minus 7.4218 is 2x, because the derivative of any constant is 0, all right? So yeah, so it looks like there's more than one answer that we could give for an antiderivative. Okay, so right now I want you to have the awareness and understanding that you see that yes, all of these are correct. If you took the derivative of either of these answers I proposed, you would get 2x either way. And so therefore, they are all antiderivatives of 2x, okay? So there are many answers. What do they all have in common though, okay? There might be these three answers that I proposed, but are they just completely random and there's no pattern or connection to them? It looks like that x squared plus any constant would work, okay? And then that's in fact the truth, and that's the theme. So here's what we do. We will always give the answer this way. We'll find the antiderivative, like whatever it is, like, and I haven't given you any rules yet. I haven't told you the procedure. I'm just, for now, I'm throwing something easy out there, like we can all agree the derivative of x squared is 2x, okay? So we would give that, and then we'd say plus c. And then that capital C just stands for any constant. It's unspecified, but it just means that the derivative of x squared plus any constant that you could ever think of is 2x. And we call that capital C the constant of integration, okay? All right, so our answers are going to look like that. Whenever we're looking for the antiderivative of something, it'll be the answer plus C every single time. And right now I want you to have the awareness that you understand why that capital C's got to be there, right? Or just because of this, the derivative of the answer, whatever it is, plus any constant is going to work, because the derivative of any constant is 0. This will always 0 out when you check it, all right? So I want to emphasize that, that it is any constant, okay? And it's unspecified, and we don't know what it is. It doesn't matter. It's just there. It's symbolically, right? And it will always 0 out when checked. All right, so that's why it's there. Okay, now, so that's one of our most basic and fundamental ideas about antiderivatives. Let's emphasize one more point though. Remember, this thing right here is called the differential. So let's think about all the parts to this kind of problem. We got this thing that is called the integral sign, and it tells me I'm looking for an antiderivative. I've got the function I'm looking for the antiderivative of, and then I've got this dx. It's going to be d something every time, and it's going to indicate that whatever the variable is. It could be dx, dy. You got the whole alphabet, but it'll be d something, and it'll indicate the variable. So let's keep that in mind. Now, let's look at this one. So how would you read this? It says the antiderivative of 3r squared dr. Okay, So when I look at this, that's my differential, and that says r is the variable. Okay. And otherwise, I'm looking for something that if I took the derivative of it, I'll get 3r squared. Now, I haven't showed you any rules yet. I'm not to that point. I don't want to throw the rules, the procedure in yet. But could you accept that, what if I put x to the third power? Would that work? What's the derivative of x to the third power? It'd be 3x squared. It seems like that would work, right? Let's just say I propose that. I'm not saying you have to figure that out on your own yet. I'll give you the rules in the next video. And you'd say, well, that does work. The derivative of x to the third power is 3x squared. But if I write that, I'm overlooking that r is the variable. Okay, you get the idea? So I've got to pay attention to what I give the answer as. I've got to make sure I include my constant of integration, but I've got to pay attention to the variable too. So I would actually want r to the third power plus c. Okay, all right, that would be it. R is the variable. Now, just like my original analogy of multiplying and factoring, you could always check your answer, all right? You might say, did I factor 6 correctly? Well, what's 2 times 3? If it's 6, then you did it right. Okay, so if I was going to check this, if I'm ever unsure, then in this case, I'd be finding the derivative with respect to r. R is the variable of r to the third power plus c. And that's going to be, so how do I find the derivative of r to the third power? Bring that power down. So subtract 1, 3r squared. And plus, what's the derivative? What's that capital C again? That represents any constant. And the derivative of any constant is 0. So, okay. But that just amounts to 3r squared. And so then that's correct. All right. The antiderivative would be such that if I took the derivative of it, I would get this thing right here, 3r squared. So I could check it like that. Okay. What about this one here? What's the antiderivative of 4 dt? So this time the function that I'm trying to find the antiderivative of is just 4. So I'm trying to think of something, and again, I haven't given you any rules yet. Right? We're not worried about that. Okay, we're just playing around with the ideas a little bit. What would I take the derivative of to get 4? How about 4x? What's the derivative of 4x? It's 4. It is 4. Okay. So we learned our rules for derivatives, and that is correct. The derivative of 4x is 4. But then if I do that, I'm losing track of the variable. Like in math, once you get to algebra and beyond, we have variables. We have unknowns. Okay? That's what variables are. There's constants, such as 4, where 4 is a definite number, and it will always be 4. And then there are variables such as x, which can take on different values. They can change, etc. So here, yeah, I mean, I kind of got the right idea, but again, I ignored the fact that the variable is t, okay? So right here, I'm looking at that differential. I'd say t is the variable. And I can't overlook that. It would be easy to overlook that in this problem, okay, this particular problem. All right, so let's fix that. So what I want is 4t. Yes, the derivative with respect to t of 4t plus any constant is 4. Okay, all right. So I'll give you the rules, the procedure for finding the antiderivatives in the next video. In this video, what I want you to have gotten out of it is a recognition of the symbols that we use, the concept of an antiderivative, the concept of the constant of integration, and the awareness that we have to pay attention to whatever the variable is that is in play for the problem at hand.